Good morning, students. Student, in last video, I told you the equation of standing wave in bound medium having rigid boundaries. Now, what will happen if the boundaries are free? So, I told you if, equation of wave y1 equal to a sine omega 2 pi t upon t minus x upon lambda. This is the equation traveling in positive x direction. And if it is reflected from free boundary, if wave is reflected from free boundary, then that one equation is y3. I take suppose y2 here, so there occur no change of phase but direction of rotation change, so that a sine 2 pi, I have explained you there. So this is the equation of wave traveling in positive direction, and after reflection from free boundary it becomes this. So these are two waves of same amplitude and same frequency. So superposition of these two waves will produce standing wave whose displacement y equal to y1 plus y2. So it is a sine 2 pi t upon t minus x upon lambda or plus a sine 2 pi t upon t plus x upon lambda. So now here formula of sine c plus sine d. So I have told you sine c plus sine d equal to 2 sine c plus d by 2 or cos c minus d by 2. So c is this whole and this. So when we add x term get cancelled and divide by 2, we get 2a sine 2 pi t upon t and cos this minus this, we get minus 2 pi x upon lambda. Cos minus theta equal to, cos theta by trigonometry. Therefore, you can write here it as 2a cos 2 pi x upon lambda sine 2 pi. Actually, this is the equation of standing wave in a medium whose boundaries are free. This is the equation of standing wave in a bound medium whose boundaries are free. And you can write it as also the y equal to a sine 2 pi t upon t, where a is the amplitude, where a is equal to 2a cos 2 pi x upon lambda, and here a is the amplitude of resultant standing wave. Okay. Now this is so that a varies with distance x periodically. So sine and cos function are periodic function. After a certain value of theta, we get the same value. After every change of 2 pi, we get same value. Now we come here in this case, position of nodes. Position of nodes. When boundaries are free, then where will be the nodes? I have told you that when standing wave is formed, there are certain points where particles of medium do not oscillate at all. Those points are called nodes. So the amplitude of wave, of standing wave, when boundaries are free is A equal to 2A cos 2 pi x upon lambda. This is the amplitude. This is the amplitude of standing wave when boundaries are free. So at nodes A is equal to 0. So 2A cos 2 pi x upon lambda is equal to 0, or cos 2 pi x upon lambda is equal to 0. If cos theta 0, then theta you know odd multiple of pi by 2. Therefore 2 pi x upon lambda 2n minus 1 pi by 2, where n equal to 1, 2, 3, 4. And hence here we get x. What is x? The position where nodes are obtained. So from here x equal to 2n minus 1 lambda by 4. Putting n equal to 1, 2, 3, 4. Putting n equal to 1, 2, 3, 4, so on. We get nodes at x equal to lambda by 4. Now you put 1, 2, 1, there 2 minus 1, 1, so lambda by 4. 3 lambda by 4. 5 lambda by 4. 7 lambda by 4. So as these points we will get from open boundary, from free boundary. So now in case of free boundaries, nodes are at distance lambda by 4 from the boundary, not at boundary. In case of real boundary, there was node at the boundary. Here it is at distance lambda by 4. Now position of antinodes. Position of antinodes. At antinodes, A equal to plus minus 2A. So 2A cos 2 pi x upon lambda plus minus 2A, or cos 2 pi x upon lambda plus minus 1. Dear student, I repeat again and again, please be strong in your mathematics. Many things people don't understand in physics because of mathematicians, they keep on avoiding the situation. No, whatever required, that much only you make it clear. What is mathematics? I told you cos theta is equal to plus minus 1. So theta is equal to n pi. Cos 0, 1, cos 181, minus 1, and so on. So 2 pi x upon lambda is equal to plus minus n pi, and therefore x equal to n lambda by 2, where here n equal to 0, 1, 2, 3, 4. यहाँ पर n 0 होगा क्योंकि cos 0 1. तो पुटिंग n equal to 0 1 2 3, putting here n equal to 0 1 2 3 4 and so on, we get the position of nodes, antinodes, position of antinodes at x equal to 0. In case of free boundary, at the boundary there will be always antinode, while in case of free boundary, at boundary there is node x, or then lambda by 2, then 2 lambda by 2, 3 lambda by 2 and so on. So I have told you equation of standing waves in case of rigid boundary as well as free boundary. I request you to learn this thing, that when boundaries are rigid, so equation of stationary wave may be dash 2a sine 2 pi x upon lambda cos 2 pi t upon t. If I take equation traveling wave in x direction as y equal to, this equation will be there comes minus sign. Here minus sign is not any difference, that makes no any difference if we write plus or minus. और मतलब ऐसा बनेगा जब when y equal to a sin 2 pi t upon t minus x upon lambda is the wave traveling in positive direction, and after reflection we get another wave and they superimpose. In case free boundary, तो था rigid boundary के लिए rigid boundaries. Free boundary के लिए क्या होगा? y equal to 2a cos 2 pi x upon lambda और sin 2 pi. This equation of standing wave will be obtained when our progressive wave is given by y equal to a sin 2 pi t, and for free boundaries we get this equation. But if anyhow, listen me, this is very important fact here. Actually, cos and sin both function are periodic, so they can both represent. If I write y equal to a cos 2 pi t upon t minus x upon lambda, this may also represent progressive wave traveling in positive x direction, and we get boundary y1 है ना, boundary. So after reflection, equation of wave y2 equal to a sin 2 pi, a cos 2 pi t upon t plus x upon lambda plus pi. Because in rigid boundary there occur change of phase of pi radian, or it will be again cos 180 plus theta equal to minus cos theta. It will be minus a cos 2 pi t upon t plus x upon lambda. People ask these questions. Now boundary are free, then equation of reflected wave. If this is the wave, that y3 will be, there occur no change of phase, only direction change take place. So that will be a cos 2 pi t upon t plus x upon lambda. So when this and this wave superimpose, तो cos C minus cos D. तो for rigid boundaries, rigid boundaries. तो y1 y2 सुपरिम्पोज होगा तो y will be cos C minus cos D होता है 2 sin C minus D by 2 plus D by 2 है भाई. So we will get here minus 2a sin this plus this t का x cancel तो sin चलो 2 pi t upon t और sin this minus 2 pi x. So sin minus होगा तो it will be 2a sin 2 pi x upon lambda and sin 2 pi t upon t. Because I have found student confused because we learn standing wave like this. के one function sin other cos or sin. If both come sin, how they have come? How this both term has sin function. So it is if the wave is written by in terms of cos, and if y1 y3 coincide superimpose, then a resultant wave y equal to होगा y1 plus y3, or it will be cos C plus cos D is equal to 2 cos C plus D by 2 and cos C minus, so it will be 2a cos, equation finally आ जाएगा this, है भाई, और cos 2 pi t upon t. So you may get equation like this also. Here this is the amplitude. But remember कि in case of rigid boundaries, there is always node at the boundary. In case of free boundaries, there is antinode. I will be giving some question here in coming video, please. But learn this. Actually, the formation of this wave, mathematical equation of this wave will help you to understand vibration of different structure, like air column, like wire, like road. We will learn here. And I told you vibration है ना of bound medium produce standing wave. Okay. So let us come to the next video. Please share the video, like, and please watch the video carefully when you are alone, and ask your friend to subscribe my channel, share the video, like the video. I hope everyone understand my videos and find something different from others. So please viral the videos. Thank you.